So today we are going to continue our study of parallelograms, but instead of just being parallelograms, we are going to go ahead and look at specific kinds of parallelograms. We're going to be looking at squares, rhombi, and rectangles. Now, while I know that you know the definitions or you know the basics of them, we're going to actually be a little more formal with their properties and with their characteristics. So let's go ahead and get started with that. So squares, rectangles, and rhombi are parallelograms, so they have all of the same characteristics of a parallelogram. So all of those properties that we've learned about parallelograms over the last 2 days, they have. So their opposite sides are parallel. Okay? Their opposite sides are also congruent. Their opposite angles are congruent. Their adjacent angles are supplementary, and the diagonals bisect each other. So all of those are going to hold for rectangles, rhombi, and squares. So let's start with the very basic of them, and that would be a rhombus. A rhombus is a parallelogram with 4 congruent sides, so we know that our sides are congruent. Okay. Our diagonals in a rhombus, and this is a new definition, are perpendicular. So we know that all 4 of those angles there in the center are right angles. So CE is perpendicular to BD. We also know that each diagonal bisects a pair of opposite angles. So it's going to bisect this angle right here and this angle right here. It's also going to bisect this angle and this angle. Now, the angles opposite these, because those are congruent and because they're bisected, these angles are also going to be congruent to the ones opposite them. So these are congruent as well. You should be able to see with any property that we have that, well, even angle side angle with hypotenuse leg, anything, that the rhombus is really made up of 4 congruent triangles. So those 4 triangles inside my rhombus are congruent. So triangle ABC is congruent to triangle ADC, which is congruent to triangle ADE, which is congruent to ABE. So all 4 of those are congruent. Okay. A rectangle, its definition is just a parallelogram with 4 right angles. So these angles are right. Okay, and because it's a parallelogram, we know that the sides opposite are congruent. Okay, we also know that the diagonals bisect each other. We know that their consecutive angles are supplementary, and we know that the opposite sides are parallel. But in a rectangle, the diagonals are actually congruent. So if I drew in this diagonal and this diagonal, they are going to be congruent. So HF is going to be congruent to EG. Okay. We also know that each angle is right by definition. Okay. I don't know why I have that slide in there twice. All right, a square. Now, we're used to seeing squares drawn as a square, right? So everything is squared up, so that doesn't look like a square, so that it looks like a square. So we're used to seeing them like this. They can also be drawn this way. This looks a little bit off. But a square is a parallelogram with 4 congruent sides and 4 right angles. So there is my square. The other thing with the square is we have a theorem that says a quadrilateral is a square if and only if it is a rhombus and a square. So remember, that means that that definition is reversible because it's got that if and only if statement, and the best definition you can get. So all things that are true about a rhombi and a rectangles are also true about squares. So we've got all those properties. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, adjacent angles are supplementary, or consecutive angles are supplementary, I should say, not adjacent. Diagonals bisect each other. Diagonals are perpendicular. Each diagonal bisects a pair of opposite angles. Diagonals are congruent, and each angle is a right angle. So the square has every property that we've discussed over the last week. Very highly specified of the parallelograms. So here I have a parallelogram, and I want to choose the best name and then find the variables. Right now I'm looking at this, and it looks like it is a rectangle. Okay, and it's a parallelogram, which is going to lead me to this angle right here, and this angle are congruent because those sides are parallel, and consecutive interior angles are congruent. So this would also be congruent. So all four of those angles are 90 degrees. So absolutely fits the definition of a rectangle, but we still need to see if it is a square. So because those sides are congruent, opposite sides, we can find the values for x and y by setting the sides equal to each other. So x plus 31 is going to equal 5x minus 9. So if I subtract x from both sides, I'm going to get 31 equals 4x minus 9. If I add 9 to both sides, I'm going to get 40 equals 4x. If I divide by 4, x is going to be 10. Okay? Think about it tonight. Maybe I'll ask you tomorrow what property tells us that we can switch the sides that those are on. Okay. So we think that x is 10, and then the y sides are also congruent. So 4y plus 5 equals 2y plus 35. So if I subtract 2y from both sides, I'm going to get 2y plus 5 equals 35. If I subtract 5 from both sides, I'm going to get 2y equals 30. If I divide by 2, y is going to be 15. All right. So we found x and y. Now to check to see if it's going to be a square, even though it definitely doesn't look like one. You guys know I don't like to draw things to scale. I'm going to put x in, 10 in for x, and these sides are going to be 41. If I put 15 in for y, 4 times 15 is 60 plus 5 is 65. So this is definitely a rectangle. It's not a square. All right, so for each parallelogram, we want to choose, again, same thing, best name and find the values. So right now we've got the markings to say that all of my sides are congruent. Okay, so we know that at the very least it's going to be a rhombus. Okay. And we should know right off that yes, it's probably going to be a rhombus because this angle is 104, which means this angle is going to be 104. Since this angle and this are supplementary, we know that this angle will be 76. I'm going to double check my math because you guys bust on me when I make mistakes. So this angle x is going to be 76. So definitely not a square or a rectangle because I don't have right angles. Okay, so then I'm just going to find y by setting it y, 3y equal to y plus 8. So I'm going to subtract y. I'm going to get 2y equals 8. I'm going to divide by 2, and y is going to be 4. So x is 76, y is 4, and our shape is a rhombus. Okay. Last example. I have a rhombus here, and we want to find the measure of its numbered angles. And you guys know me, I don't like to make it so you can definitely start at 1. You could, but sometimes it's easier to start elsewhere. Since the diagonals are perpendicular, that means that all of those middle angles are right. So that means that the measure of angle 2 is 90 degrees. Okay. We know that this angle here is 34, and it's going to be congruent to angle 3, so that's going to be 34 as well. Angle 1 plus the 34 has to equal 90 degrees. Okay. So the measure of angle 1 is equal to 90 degrees minus 34 degrees, or 56 degrees. I know that when we talk about triangles, we know that some of their angles is 180 degrees, but I skipped to that because it was just kind of common sense, right? If we've already got a right angle, then there's only 90 degrees left in that triangle. Okay. So today, we talked about all of the properties of squares, rhombi, and rectangles, and we used them to solve some problems that dealt with those. You guys need to thank my 6th period because I recorded during planning and, like an idiot, deleted it. And so they're sitting here very quietly so that you could all have it done. Have a great day. I'll see you in class tomorrow. Saturday.